Hi, this is Dan Bullard, retired electronics engineer, sitting in the take my house, but again, it's July 31st. So I made it. I'm 68 years old, so yay. I want to talk to you about Nawk. As in, knock knock, who's there? Nawk. Brian Kernighan and, what was his name, Aho, another guy, AWK, they wrote awk as a scripting language to be able to manipulate text and stuff. And it's part of grep and sed and all that stuff. Awk is really, really powerful. And I tell this story, when I was at Tectronics, we had a roundtable meeting, and people would go around the room and talk about what they were doing. And I mentioned that I had written an awk script to convert the datalog files on the Teradyne into CSV files, which are comma-separated values, so that they could be read by Excel. Almost everybody uses Excel to deal with datalog files. Even Teradyne, for a while, you could use an Excel file to control a tester, because everyone was so familiar with how Excel worked. By the way, this is the weather on July 31st. Right now it's supposed to be sunny. So there you go. That's the weather for you. We were doing this meeting, and I mentioned that I was using awk to convert Teradyne datalog files into CSV files, and then I would upload them automatically. I wrote a cron job to automatically upload these converted files to the server so that people could go through them, because nobody looks at the data. This is not like sitting around with Radio Shack voltmeters and signal generators, and somebody's looking at numbers and writing them down. No, these tests go fast. These tests go really fast. I mentioned a program that I wrote for, thank you. I mentioned a program I wrote for analog devices. It tested XY accelerometer. Tested it in a quarter of a second. Not only tested it, but calibrated it. So tested and calibrated, and then stored the calibration values in the device in a quarter of a second. A quarter of a second. So nobody sits there, I don't do that, going through test by test with a voltmeter and writing things down. We don't do that. The tester does all that stuff. So our job as test engineers is to make these tests, write these tests to go as fast as possible. The faster your test time, the more the handler indexing time becomes an issue, because the handler's got to pick up the part, stick it in the socket, the tester tests it, and then the handler pulls it out, puts it away in whatever bin it came out at, and then puts in a new part. So what's that time? It's got to be better than a quarter of a second. We're only taking a quarter of a second to test the part. So to take a part out of the socket, put it where it's supposed to go, put a new part in the socket, and close it up so that the part can be tested, that's got to be faster than a quarter of a second. That's pretty fast. Okay, so I was in this meeting and I told them I wrote this script, and somebody says, well, why didn't you write it in Perl? Because I don't know Perl. I do now. At the time I didn't know Perl. And it's a sad replacement for awk, really sad. And B, the Teradyne ran on Solaris, and it had awk, but it didn't have Perl. So I would have had to install Perl on the Teradyne, and I don't want to do that. I don't want to get in there and muck things up, It's already got awk, and I know how to use awk, so I wrote the thing in awk. Now actually, in fact, I used Nawk, which is new awk. And Brian Kernighan was involved in that too. So it's a really cool thing. So here's what it does. This script takes a Teradyne datalog file. Here's a test program, datalog. The test starts out with a continuity test. So test 1001, continuity, TXD, that's what the pin. We're doing continuity, and the low limit is minus 0.9. And the high limit is minus 0.1, and we're getting a minus 0.5. Now what is that? what we do there in continuity tests, I've done continuity tests on every tester known. Continuity test gets on the pin, and every device has multiple pins, you know that. Gets on the pin with a current force unit, either a PMU or possibly a continuity per pin measurement system, or maybe just the active loads. It applies a current to that pin. And usually, in this case, this is a negative current. We're pulling current out of the part, and that's going to cause the part to go down in voltage on that pin, and it'll go down to 0.5, 0.6, 0.7, because every pin has a diode on it to go to ground to avoid ESD damage, electrostatic discharge. So that's what the continuity test is counting on. It's counting on those ESD diodes. So we pull the voltage down, and it goes as low as minus 0.5 in this case, or minus 0.6, even minus 0.7 on some pins. So as long as it goes between minus 0.2 and minus 0.8, it'll pass. If it doesn't do that, if it goes to minus 1.5, I think that's the limit on most of these. If it goes to minus 1.5, that means it's open. And if it goes to 0, that means it's shorted. It's shorted to ground. So we're verifying that there's contact and that it's not shorted and it's not open. So we always do that first to make sure that the part is in the socket properly, that all the pins work, and sometimes they don't. I mean, sometimes these things have problems. Bad cables, like on the Teradyne, they use these cables, and if the cable is bad, and we had cases where the cable went bad, and so if the cable's bad, you got a bad wire, it'll go to an open, and so the active load or whatever it is, PMU, will pull the voltage all the way down to minus 1.5 volts, and in that case, it fails. So, and if it's a short, it'll fail because it goes to 0 volts. So that's a contact test. Okay, so we do contact. Now if we pass contact, then we can go on to the rest of the test. And so here we've got an ICC, which is power supply current. We're doing all this stuff in like a couple of milliseconds. Every test takes a couple of milliseconds. Actually, the contact test in total, might take 5 milliseconds. Might take 5 milliseconds. So we get through that really fast, and we get into the supply current test, a bunch of other things. I don't even know what this part is. We finish the test at the end. Oh, this one failed. Oh, bummer. And normally, these things are set up for fast binning. What's meant fast binning? So if it fails a test, boom, we're out there. And this failed in bin 16. Bin 1 is a good bin. Bin 16, in this case, they programmed that to be associated with that particular kind of failure. Now, the Teradyne has a datalog format that every tester has a different datalog file format. Teradyne tried to standardize them, calling it the STDF's standard test data format. It actually meant standard Teradyne data format, but standard test data format. So they tried to set a standard so everybody would follow that. Most people didn't. They stuck with their data format. But the problem is, most people don't analyze data with a Teradyne tool. They analyze it with Excel. And so the trick was to take this data log file, go through the data, and capture the data into a CSV file, comma separated valued file, because you can open it in Excel, and we do a lot of stuff with Excel. We have to do a lot of analysis on the data. For opening, and I did this with the TV tuner on a chip, when you start testing, when you do your first run, we will test 10,000 devices, save all the data, and then go through it to see if the test is doing what it's supposed to do, to make sure that we're not too close to a limit on one side or too far away from another limit on the other side. Make sure that we have consistent data. So here is the CSV file. Now I opened this because I don't have Excel. I opened this with numbers on the Mac. And so here we go, there's the contact test. And here's one that had an alarm and a failure. So we had one value, let's see, 0.5 minus 0.5 minus 0.5 minus 0.6, blah, blah, blah. And then we go to -1, -1, and -1.9. Boom. That's a failure. So here we turn the data from Teradyne datalog file format into a CSV so that the Excel thing can read it and we can analyze it in mass. We have to make sure that everything's cool, and trust me, at Maxim, we went through these things with a fine-tooth comb. Not the individual data. We basically analyzed all the data in a datalog file with Excel and then verified that we were doing the right thing. And I did get caught on a couple of things for the TV-tuner on a ship. It was like 1,000 tests. 1,000 tests. And so you can't look at each individual test until you get a whole bunch of data. So we test 10,000 parts. We then run all the data through Excel, looking for various things using, it was complex. It would take days to run this stuff through the Excel file. Then we would look at the data and see where we were. Now, how do you go from a Teradyne datalog file format to a CSV? You write an awk script. And so I don't want to cover awk totally, but here's what they do. This is an interpretive language. It's not compiled. It's kind of like Perl. Perl is interpretive and not compiled. Pound bang /bin /awk minus F. F means force. If it has an error, keep going if you can. Okay, usage. On some workstations, invoke this script with Nawk, as some functions are not supported by awk. Nawk -F dl convert.awk, and then give it the file name Teradyne datalog text file to a redirect into new file name.csv. So there you go. Now we do a begin, print, Teradyne datalog file extracted from blah, 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 blah. There's a whole bunch of stuff in here. I recommend a book on awk. It's really cool. It's a great little book, and it'll get you through it. It's basically dummies book for awk. This datalog file gets converted by the awk file into a CSV, and once it's in a CSV, we can open Excel and read it. We don't have to pay Teradyne for some kind of tool. It's pretty cool. And there are lots of web pages out there where they talk about awk, and you know, just play with it. You'll get used to it. It's kind of weird. I would use Nawk instead of awk, because Nawk at least gives you more helpful error messages if you screw up. So go with awk or gawk. Gawk is the other one. GNU, awk. Anyway, you can see that my hair has come back from my days of having COVID. I'm doing a lot better that way. At least my hair is better, my beard's better. I'm doing good. And I'm 68, so yay. So once again, from the river, this is Dan Bullard. See ya.